There you go. Waiting for people to come in. Hi, everyone. Thanks for joining us. This session is brought to you by Building Point Australia. Today, we'll be looking at IDEA StatiCa Detail, one of the concrete apps in the IDEA StatiCa set of applications. We'll keep things practical today. We'll show you how to set up geometry, layout reinforcement, and run through some simple workflows that you can apply straight into real life projects. So with that, let's get started. My name is Bao Lam Dao, or Bao for short, and I'll be one of the presenters for today's session. I'm joined by my colleague Khalid Gaidi, who is a technical support consultant in our engineering team at Building Point. How are you, Khalid?
Hi everyone. Nice to hear you.
Nice to hear you. And just a quick introduction to anyone who's new to Building Point. We're the authorized reseller for IDEA StatiCa and Trimble products across Australia and New Zealand. We're essentially your local partner handling sales, support, marketing, and training for our solutions. And on the engineering side of things, where both myself and Khalid work in, our main focus is TED, Technical Structural Designer, and of course, IDEA StatiCa. Here's what we've planned for today's session. First, I'll give a short overview of the current IDEA StatiCa applications. Next, Khalid will take you through IDEA StatiCa Detail in depth. Finally, we'll wrap it up with a Q&A session. So if any of you have any questions along the way, you can post them in the Q&A tab, and we'll try to answer as many as possible towards the end of the webinar. When you open IDEA StatiCa, you notice that there's three apps grouped into three modules: steel, concrete, and BIM. On the steel side of things, I'm sure many of you are already familiar with. We have the connection app, which is used to analyze steel-to-steel joints and base plates. But we also have the member app, which is designed for stability-sensitive members, and the connection library as well, which is a free cloud-based tool with over 1 million ready-to-use templates on the steel side. On the concrete module, there are four main apps. We have Detail, which is used for analysis of discontinuity regions and anchorage design. This comes in both 2D and 3D, and I'll explain a little bit more about that in a moment. We also have RCS for reinforced and pre-stressed cross-sections, Beam for analysis and design of beams, including time-dependent behavior, and also a member module there as well for advanced analysis of concrete members. We also group BIM as a module. This includes the Checkbot, which is an intermediate app that connects IDEA StatiCa with other software. I think at the moment there's more than 40 links available, so you can just go into the website to check if your application can link with IDEA StatiCa. And also just a viewer app, which is a free cloud-based tool that you can open, review IDEA StatiCa files, share them, and collaborate with others. For today, though, we'll mainly focus on the Detail app. But if you want to, learn more about any of the other apps, there's a lot of material available on the IDEA StatiCa website. So Detail 2D focuses on the in-plane behavior of surface elements like walls and beams. You can use it to design deep beams, walls with openings, corbels, diaphragms, pier caps, and more. The software itself comes with a range of inbuilt templates to help you get started quickly, but you can also start from a general template to build your model from scratch. There's also some other handy workflows like DXF import for geometry, which Khalid will walk you through a bit later. And most importantly, everything is fully compliant with 3600. This code support was added in version 25.0 earlier this year, so you can be confident that your design actually follows Australian standards. Detail 3D goes a bit further. It's designed for more complex discontinuities where both in-plane and out-of-plane forces and behaviors is considered. It's also worth noting that AES-36 compliant isn't here yet for this module, but it's coming soon. If you open the software, you already see an Australian flag in the design code list with a note saying that it's coming soon. But once it's released, we'll run some dedicated sessions to cover 3D detail in depth. For now, it's only available in Eurocode and American codes. And that was just a quick overview over the current apps from me. I'll now hand it over to Khaled, who will guide you through the theory and some practical workflows in detail. Over to you, Khaled.
Thank you, Bao. So let me share my screen.
Yep, just take over once you're ready to go, Khaled.
Yeah, so just I'm sharing, sorry.
Yeah,
just
no dramas.
bear with me, sorry. So I will turn off my camera.
Yep, you're sharing right now.
Okay, thank you, Bao, for brief introduction about the agenda. And yeah, so I also appreciate and welcoming everybody for this webinar. So first I will go through the detailed 2D and later I will go through the detailed 3D. So as my colleague Bao mentioned that, so today's webinar is mainly focusing on detailed applications. So we have the detailed 2D. So let's get started with detailed 2D. So in detailed 2D, first of all, so you can just bring any geometry or using the inbuilt template that we have in detailed 2D. So you can create any geometry and you can edit the template and you can go for different type of concrete material like conventional RC or maybe post tension or precast design or composite kind of concrete sections. And it is for ULS and SLS, or let's say for strength and serviceability. And here just I listed some of the main features of detailed 2D that you can always take advantage of them. Like you can add the opening, you can just go for checking the strength of the concrete, reinforcement, tendons, you can check the crack width, and also you can see the nonlinear deformation, and at the end of the day you can get the bill of materials as well. As it mentioned, so the AS3600 implemented in detailed 2D. And so based on this implementation, so we adjusted the material database. So here we have the material database for concrete reinforcement and also steel materials. And also we adjusted the nomenclatures, just like variables, just to suit the AS3600. And also we refined the calculation through the stress strain diagrams for getting the result on their serviceability and strengths as well. But the question is that sometimes, we receive this feedback, from the engineers that can we rely on this kind of application or finite element analysis or nonlinear analysis. So just I prepared, this quick hint and clue, just to remind ourselves that usually we have the permission from the codes, including AS3600. So if you go to the AS3600 and go to the sections that I highlighted here. So for example, in section 6.5, so we have actually the permission about the nonlinear analysis, and also it's about the nonlinear material effect and also geometrical nonlinearity as well. And if you go to another section, for example, section 6.6, also you have the some kind of information and also permission regarding the nonlinear stress analysis, and also clearly mentioned that the approaches like finite element analysis can be used as well. So therefore, I think this is a great idea to use the advanced tools to get the accurate results compared to whatever actually we are doing right now just by hand calculation or using a spreadsheet. And this is the main purpose of introducing IDEA StatiCa, just to eliminate the spreadsheet or hand calculation. Just we know that they are time consuming, wasting time. So simply you can use this kind of application and you can get the accurate results. So if I want to mention about the detailed 2D, as Bao mentioned, so this application mainly deal with the in-plane bending or in-plane behavior of the surface element. But the thing is that, once we are using the other kind of solution like a space gas or ETABS, we don't have any issue with designing the prismatic sections, or we call it, Bernoulli regions. Here we can see the B regions and another region that we have. So this is the D or disturb or discontinuity region. And this is the, place of pain that we cannot do or design this kind of regions in the conventional solutions. So that's why either you need to use the advanced finite element solution like Abacus or ANSYS. So later I will give you more information about this. Or you need to go through the conventional method like Strad-Antey method. And each of them has, let's say, their own limitations. But using the detailed 2D, so simply you can, just take advantage of cutting edge technology that we have it inside the detailed 2D, and you can design the disturb or discontinuity regions. As you can see here, for example, you have the beam with opening, for example, or you have actually, the concentrated of the forces at a specific region of the member, or you have the corbel. So this kind of regions, we call it disturbed region, and usually we have kind of always, let's say, headache to design these regions. As I mentioned, so the possible approaches is using Strad-Antey method, and so here just I try to give you some hint that what problem usually we have with the Strad-Antey method. So usually they are oversimplified. They are code compliance, but only for strengths or ULS, but we cannot go beyond the ULS to check the, for example, serviceability or service result they correct with, or deformation of the section. So we cannot go to that level. And also, since we are, again, simplified the method, so we are just in the linear region. So that's why, so we can say that always, we have the over-design results. And not only that, also we have, we need to go through the trial and error, especially if you want to optimize the reinforcement as well. So this is all, let's say, drawbacks of using Strad-Antey method. If we come to advanced finite element analysis like Abacus or ANSYS, so they are time consuming, they are not code compliant at all. And so at the end of the day, so you need to get the forces and then, put it in the spreadsheet, or maybe again, go through hand calculation to just, check it against the code. And not only that, so using this, let's say, fully finite element solutions. So always you need to have the knowledge about the, let's say, the parameters that you have inside the solutions. So that's why it's required user knowledge. And if the user knowledge is not there, so never ever, result can be reliable. So the 2D detail is just try to bring a new method or approach. We call it CSFM, or compatible stress field method. In short term, or in, let's say, a simple way, I can say that this is the combination of Strad-Antey method with the advanced finite element model or method. And so we combine it together, and then so we have actually the safe design. you have actually the code compliant result for ULS and SLS. And also you can take advantage of nonlinearities like material nonlinearity and geometrical nonlinearity, which already I showed you. We have permission by the code as well. And at the end of the day, so you have the more accurate result and also more economical and optimized result as well. So what is the CSFM or compatible stress field method? So this is all about the, dealing with the principal stresses. But as you can see in this slide, I prepared, some let's say graph for you. So to let you know that actually what is the, let's say, the theory behind the compatible stress field method. As you can see, in this graph, so in the top left, we have the principal stresses in the concrete, and then so we have the, the stresses in the, let me, if I can, sorry. I'm not sure if I can just highlight it, but anyway, so you have the stress in the reinforcement. You have the stress strain diagram for, let's say, softening compression. You have the stress strain diagram for crack at the maximum stress level. And also you have the compression, softening compression law. And also you have the bond stress slip, let's say, diagram as well between the concrete and reinforcement and anchorage. So just having this, let's say, technique. So we just implemented in the, by having the finite element technique. So we implemented in the software, and several validation and verification have been done to make sure that the results are accurate. And so that's why for verification and validation document, so you can always go to the IDEA StatiCa website, to the support center, and so you can get the plenty of information in IDEA StatiCa website. But after having the CSFM technique, so what result you can get, as you can see here, so you can go for topology optimization. You can look at the nonlinear deformation of the section that you are designing. You can look at the crack width, you can look at the principal stresses, you can look at the principal strains, and not only that, also you can put the reinforcement inside any section with any topology and any geometry, and get this kind of results. If I want to quickly let you know what you can do with detailed 2D, so it doesn't matter actually with what field you are working with. So as long as you are working with the concrete material, so you can use the detailed 2D. For example, here you have the wall and panels, some examples for coupling beams, walls and piles, for example, walking columns. You can use IDEA StatiCa 2D, or maybe, for beam with any topologies, like beam, with opening, deep beams, frame corners, or beam with the pre-stressing or corbels. And also in terms of the bridge engineer, so also they can use the IDEA StatiCa detailed 2D for designing the pier caps, diaphragm, pile caps, piers, and bridge deviator. And so just like IDEA StatiCa connection, which I believe that most of our participants today are familiar with IDEA StatiCa connection. So we have the templates in detailed 2D and 3D as well. So here, just I tried to show you the template that we have in detailed 2D. But let me just go to the demonstration of IDEA StatiCa detailed 2D. So from here, so you can just go to the concrete and click on the detail. So here, as you can see, you have the templates for different sections. For example, here you have the wall with the opening, you have the walking column, so you have the depth beam, you have the simply supported beam with opening, you have the frame corners, you have the diaphragms, templates, and also pier caps, and also pile cap. And finally, you have the general cross section. So in this particular example, so I want to use the general cross section to bring the DXF. So you can select the code. Here we select the Australia code, which is AS3600. So adjust the material. And then, so from here, let me, before bringing the DXF, so I prepared, this DXF in AutoCAD. And then so I can go to the DXF import. You can click on the options that you have, go to the exactly the same DXF. So here I prepared it, in different manner. So for example, I want to select the middle one, and then so I can just select the geometry of the corbel. And as you can see here, also I have the opening as well. And I try to just, come with the fillet in the opening. So just to let you know that any type of geometry, you can just create it in AutoCAD and then so bring it to IDEA StatiCa Detail 2D. So here we have the geometry, already we brought it in Detail 2D. And then so from here, as you can see, you have different type of support. And if you have any load transfer devices, also you can, use this one. Let's here use the linear support as well. So by default, it goes to the edge 1, but simply you can, just adjust it. So here we have the compression only a spring, which is mainly we use that actually for base plate design once the concrete block is interacting with the soil. But you can just adjust the boundary condition as you wish. So here just I did it. And then so for transferring device, so I can again, go to the same DXF, and then as you can see here, so I can bring it using this coordinate. So exactly, but let me just go back there and then so take advantage of the template that we have, or here. Okay, so we have the bearing plate. You can click on that. And again, so if it's not exactly at the edge that you want, so simply you can change the edge by going to the options. So for example, here I can put it on edge number 3. And from here, so you can, just update the property of the any entity or component that you have. For example, here just I want to increase the thickness from 20 mm to 30 mm, and then so here you can just play with the options, and you can place the bearing plate. As you can see, it's very simple, just working with this software. So let me just put it in the proper place. So I want to put it here. So after that, we can go to the load. So here I will apply the load, as you can see again. So you can apply the dead load and live load, or permanent and imposed. So you have different type of loads. You have the self-weight, surface load, line load, and point load. So let me apply this self-weight to entire section, and then so I will go to add another load, but this time as a live load, just for demo purpose. So I will add the point load to the bearing plate. And so from here again, so you can, just change the location of the load. As you can see, you can put the load in any location, even inside the concrete section. Let me go back to bearing plate. And then so from here, I can change the magnitude of the load. Let's say, for example, from 10 to 30. And also you can change the direction of the load, maybe in X direction, or again, Z direction. You can change the direction upward, downward. So all this possible. So let me just, again, put it in the Z direction. Okay, so after putting the loads, so you need to define the load combination. So you can go to load combination. So here I have the, one dead load, which is self-weight, and also live load. So here I want to just consider, a combination for serviceability. So I will name it as service. And then so let's go for short term. I don't want to change, the factors. And then so the next one I will go for strength. So here just simply I will say strengths, and then so I will change the type of load combination to strengths as well. And then again for demo purpose, let's say here I will say 1.35 and then 1.4 for dead load and live load respectively. So here we have the strength and serviceability under combination. So I can bring the reinforcement even from the DXF as well. But here also you have the template of reinforcement. So for example, if I click on the reinforcement around the opening, as you can see, the software automatically and smartly can detect the opening and put the reinforcement around the opening. And from here again, so always at the right hand side by selecting any entity, so you have the options to edit the entity. So here, so I will just remove this one. And so the purpose of this demonstration is to let you know. So you can bring the even DXF from, the reinforcement from DXF as well. So I will go to the same DXF file, and then so here I can just press Control and select all the reinforcement again, so just I put the reinforcement in this way just for demonstration purposes. And then so accept. So right now here I have it. And again, so from here I can work with the reinforcement. So here you have different type of views. So right now I'm in the 2D view. I can go for the 3D view of the model, and also I can go to the real 3D. So if I go back to the wall, or let's say, the corbel itself, I can even increase the width of the corbel as well. So for example, here, I can increase it, to, let's say, half meter. And then I can come back to the reinforcement, and I can, if I go to the real 3D model, so I can go for multi-selection mode, and then I will select all the reinforcement. I want to have 3 layers of reinforcement, just like this. And then so even you can, change the diameter of the reinforcement as well. But here the thing is that since we are dealing with the corbel, so we know that, we cut the corbel and this column is continuous. So that's why you can change the anchorage type at the, let's say, end of or beginning of the section. So here I just apply the continuous reinforcement by selecting, this 3 reinforcement. If I go back to the 3D real view, so here, and I will change the continuous bar, because these bars are continuous, to the end of the, or let's say, continuation of the column. So that's why here you can see how the reinforcement are presenting. So, and then so you can, after putting the reinforcement, so simply you can go to the tools tab. So here we have the cutting edge technology, which is the topology optimization. So you will get the compression and tension zone with the red color and blue color. So for example, here you have the compression zone, the red zone. And if you recall, so we put the load exactly at the top of the bearing plate. So that's why here, very specifically, you can see how the compression and tension zone is shown by the software. And based on this compression and tension zone, so you can update the reinforcement, you can put the reinforcement, just to have the better design. So you can run the analysis, and then here you have the summarized result of the concrete reinforcement and anchorage, and under strengths and also under serviceability. So if I go to the summary, so as you can see here, you have the strengths in the concrete, in the reinforcement, and in the anchorage. Okay, so all you have with the utilization ratio. And you can go to the strength. Here you can look at the stress limit check. You can look at the principal stress as well. So if I go to the stress check value, which is actually the utilization ratio for the stress, and then you have the principal stress, you have the principal strain, and also plastic strain as well. And also you can look at the direction of the stresses as well. So let me go to the anchorage. So you can look at the utilization ratio for the bond stress, and also utilization ratio of the forces. And also, if you want to look at the real value of the bond stress, you have the option to look at the value of the bond stress, the values of the forces in the reinforcement, as you can see here. So you will get all this detailed information. And also you can look at the limit force of the reinforcement. So here the software quickly show you actually the forces, and also the limit force that you have for each reinforcement according to their placement. And in terms of the crack width, which is under serviceability, so you can click on the crack width, and then here, so we specified that the limit crack width is 0.3 mm. So you can again look at the location of the crack, if you remember. So by doing the topology optimization, so we are actually in the tension zone at that location. So you can see the graph, just by clicking on each location, and see the graph as well. And you can go to the utilization ratio of the crack width as well, the real crack width value versus the limit one. And also you can look at the deformed shape, let's say linear deformed shape of the section under applied load, and also under short term, if you remember. So we applied, the serviceability under short term. So here we have it. And also you can go to nonlinear deformation of the section, and from here, so you can play with the scale, just to feel the behavior of the section that you are designing. Okay, and also you can look at the tensor of stresses as well. So in the, let's say, the stress in direction 1 and direction 2, and also the strains. And again, so you can look at the direction of the stresses for tension and compression stresses as well, or zones. And finally, you can go to the report. So by the way, here you can just customize your report as you wish. So once you just selected, what kind of report you want to include to the report, you can go to regenerate, and here you have the detailed report, including the reinforcement information and all the result that we reviewed, the stresses, strain, the direction of the stresses as well. So you have all this information, let's say graphically, and also in tabulated format for strength and also for serviceability. And also you can get the bar bending schedule for the reinforcement as well. And also you can include the explanation and theoretical background of the method to your report as well. So this is about the detailed 2D. So hopefully it's clear. So now we can go to detailed 3D. So if you remember, we said that once we are dealing with detailed 2D, so we are dealing with the in-plane bending. So now with having detailed 3D, so we can also deal with the out-of-plane bending as well. So together with in-plane bending. But the main purpose of developing detailed 3D is to design the anchors, okay, in complete manner. I believe that, again, those who are familiar with connection application, so once you want to design the base plate, so usually you will get this kind of information from the connection application, and some of the checks for the anchors cannot be done sometimes. So here just I summarized for you, for example, pull-out failure, fastener combined pull-out and concrete failure for post-installed bond anchors, and also concrete splitting failure. So this kind of checks is not included, in the check for connection application. So the reason why to use the detailed 3D, so you can send the information or the forces that you get from the connection application for the anchors, you can send it to detailed 3D. And the main drawback that we have actually in connection application is lack of reinforcement in the concrete block once we want to design the concrete in connection application. So that's why this is another reason for us to send the information to detailed 3D and use the detailed 3D to design the anchors completely. And that's why here, so you can add the reinforcement inside the concrete block and take advantage of the supplementary reinforcement, which is again somehow permitted by the code to take advantage of the supplementary reinforcement to strengthen the concrete block instead of let's say increasing the size of the concrete, or sometimes increasing the grade of the concrete. So usually we don't need to do that once we have the advanced tool to design the concrete block. So this is the main reason. So first of all, so you can put the reinforcement inside the concrete block, and also you can take advantage of the compatible stress field method, which already we explained, and then so you can have the detailed results of the section for concrete and also for anchors as well. And again, so just like detailed 2D, so we have the stress compatible field method, but here in detailed 3D we have it in 3 dimension. Okay, so by taking advantage of Moore column and Rankin model, and also with the help of Moore circle theory. Okay, so based on this again approach, so the detailed 3D has been developed, and also the several tests have been done to just make sure that the results are accurate. And that's why, so right now we are very confident with the result of both detailed 2D and 3D. Again, so always you can go to support center in IDEA StatiCa website to check the validation. That is the result of detailed 2D and 3D already compared with several fully finite element solution like Abacus, ANSYS, ADINA, and also with the experimental test as well. And again, so having the 3D CSFM, so you can go for designing any type of or any geometry of the base plate. So here I try to just give you some feeling about the detailed 3D. So what basically you can do with detailed 3D, as you can see here, you have the funny shape of the concrete block. And so just you need to use the features that you have in detailed 3D and come up with this kind of geometry. You can put the reinforcement and you can design the concrete block. And as you can see again, so you have the, for example, pile cap, you have the let's say combined footing, you have the non-standard type of footing, you have the casting plate as well, and also you have the corner base plate as well. So all this possible easily, and you can do it in detailed 3D. So let me quickly show you detailed 3D application. So just to get some feeling. So here again, just like 2D, you have the template. And since the Australia code for this current version is not supported, so I will go to Eurocode. So you can select the either the template, or you can go for general section, just whatever I showed you under detailed 2D. But here I just take advantage of the ready template, and here I have this concrete block. So you can edit everything again here just by selecting the component. So here, since we have the base plate, so that's why here we have the compression only spring. And so you have the information about the base plate. So here you have the different method to transfer the shear force from the base plate to concrete. So for example, you have the shear log, and again everything is editable. So I can just play with the parameters that I have here. I want to put the shear log exactly at the center of the base plate. I put it here, and you can rotate it. For example, here I can rotate it by any angle that I want. Maybe you want to just play with the length of the shear log. So here, let me just put it as 0.5. And then, so this is how you can actually work with the shear log. And also you have the friction and also definitely anchors. So in terms of the anchor, so here you have also the interconnection with a base plate. So it is through the axial force and shear force. And again, so you have the options, to edit the anchors as well. And again, just like 2D detail, so you can add the loads at any location of the base plate. So you have the type of anchorage, you have the template of the reinforcement, you can put it there, and then after defining the load combination, so you can just run the analysis. And just in a few seconds, you have the results. Again, for concrete, reinforcement, and anchorage, you can look at the stress flow or direction of the stresses in 3D view. You can go to the strengths, look at the principal stresses of the concrete. So here you have the equivalent stress. You have the strain as well. And also, again, you can go to the direction of the stresses. You can also add the section cut. For example, here I want to add the a section cut, to present the results in a better way. So here I can go for this, and then so all other results can be seen on that section cut. And in terms of the anchorage, so you can see the, again, the bond stress, you can see the forces, you can go for checking the utilization ratio for the bond stress and also for the total force that you applied, and then you can go for nonlinear deformation of the base plate. So here you can just play with the scales. And again, so since right now we are in the 3D detail, so that's why you have actually now 3-dimensional stresses and strain, and you can check this stresses as well. Let's say, the stress in tension, compression, and so on and so forth. And finally, again, just you can go to the report. You can customize the report. And this is the report. By the way, you can export the report to PDF, editable Word file, and also you can link the IDEA StatiCa to your physical printer as well. Okay, so I think that's from my side. Bao?
Yep. Let me just share my presentation again. Put on the camera as well. Yeah, so I'm just going to do that. So thank you, Khaled, for the in-depth presentation. Now it's time for a quick Q&A session. So if any of you have any questions, just post them in the Q&A tab and we'll go through as many as possible. I think we have a few. First one from Debray. He's asking if the software have a steel section / connection with external post-tensioned connection. I believe you're probably asking if IDEA StatiCa can handle steel connections where external post-tensioning is applied. We have Nick in the room who's our steel expert, but I think the connection module itself primarily handles steel-to-steel connections. And when it comes to applying some sort of post-tensioning, external post-tensioning force to that connection, there has to need to be some sort of workaround. You probably have to represent the effect of post-tensioning as additional forces or moment applied to the members and nodes itself. The software is designed to have some sort of full interaction between the steel connection and the post-tensioning effects. That is my view on it. Khaled, I don't know if you have any other comments to that.
Yeah, you're right. You're right. But finally, if you want to consider the effect of post-tensioning, let's say internal or external, so you can use the detail 2D mainly. Yep. So right now we have the feature for pre-stressing and post-tensioning in detail 2D. So you can just consider those effects in detail 2D.
Yeah. Thanks, Khaled. Also a question from Tony as well. Does the concrete module interoperate with robot structural analysis? The quick answer is no on the concrete side, yes on the steel side. We currently don't have any full BIM link with IDEA StatiCa detail, the concrete side yet, but we have one software that we're going to release the full live link to in the next release, and that is ETABS. So any ETABS users out there, they should be able to fully link ETABS to IDEA StatiCa detail in the next release. We'll talk a little bit more about that in our upcoming session as well. Yes, so I think that was all the questions for today's webinar. And just going to wrap some things up before we finish off. I just wanted to let you know that a recording of the session will be uploaded to our Building Point Australia YouTube channel. So if you like some more tips and tricks on IDEA StatiCa or Tekla, I'd recommend subscribing there. If you'd like to try the software yourself, there should be a 14-day free trial available from the website. There's also a free online campus course. This is a self-paced course which combines both theory and hands-on examples. So it's a great way to learn the software. And for ongoing help, don't forget about the support center. You'll find tutorials, knowledge-based articles, verification examples, and much more. And if anyone here has worked on a great project using the software in Australia or New Zealand, would love to feature it as a case study. So just get in touch with us if you want to feature it. It's just a nice bit of free marketing for your firm. And if you're interested in detail, it's available as a standalone app. So just reach out to us if you want to talk through some pricing options. For sole traders and early stage firms under 2 years old, there's some special offers available subject to conditions. And if your company already has a steel license, you can upgrade to a complete license, which gives you access to both steel and concrete modules in one package. Before we wrap it up, I just want to flag our upcoming IDEA StatiCa 25.1 roadshow. We'll be running in-person sessions in Brisbane, Sydney, Melbourne, and Perth between the 20th to 27th of October this year. Lunch is included, and we'll just have some IDEA StatiCa staff joining us for the sessions, and we'll run through the new features in version 25.1, including AS36 compliance in detail 3D. But we'll also look into workflows with eTabs. It's the checkboard link I mentioned previously. Some workflows when it comes to anchorage design and other new additions as well. Spaces are limited, so it's worth reserving early. And that's it from us today. Thanks again for joining, and we hope to see you at one of these roadshow sessions. I'll send up a link and follow-up link to attend those sessions shortly to all the attendees as well. Thank you all.
Thank you all.
Thank you.